Welcome to our presentation on the hydraulic pumps and its classifications. In this video, we will delve into the world of hydraulic pumps, exploring their types and key characteristics. Here are the outlines. Let's start with a fundamental question. What is a hydraulic pump? A hydraulic pump is a mechanical device that converts mechanical energy into hydraulic energy. In simple terms, it takes power from an external source, such as an electric motor or an engine, and uses that power to move hydraulic fluid, which can then be used to do work. In hydraulic systems, pumps are often referred to as the heart because they play a crucial role in generating the force required to move fluids. They create the necessary fluid pressure that drives hydraulic cylinders or motors, enabling the system to perform work. On to the next slide, classifications of hydraulic pumps. Hydraulic pumps can be classified into several categories based on their operating principles, design, and specific applications. Here are some common classifications. First, classification based on displacement, which means pumps can be classified based on how they displace or move fluid. The first one is the positive displacement pumps, also known as hydrostatic pumps. These pumps move a fixed volume of fluid with each cycle of operation. Examples include reciprocating pumps like that of the piston pumps and rotary pumps like that of gear pumps and vane pumps. In fact, this type of pump is the topic of focus, namely internal, external, and Gerotor gear pumps that we are going to go through more later on. The second one is the non-positive displacement pumps, also known as the hydrodynamic pumps. These pumps do not move a fixed volume per cycle, and instead they rely on fluid velocity and kinetic energy, so they are more suited for high flow, low pressure applications. Now onto the second classification, the classification based on delivery. This means the pumps can also be classified based on the consistency of their fluid delivery. The first one is the constant delivery pumps. These pumps deliver a fixed and consistent volume of fluid per rotation or cycle. Example includes centrifugal pump for water supply, which is commonly used in a municipal water supply system where it maintains a consistent flow rate of water to meet the daily demands of household. The second one is the variable delivery pumps. So these pumps allow the operator to vary the volume of fluid being delivered. So this is useful for adjusting the speed of force of fluid hydraulic components in a system. So example includes automotive fuel injection pump. So in modern cars, the fuel injection system often uses a variable delivery pump. So this pump adjusts the delivery fluid to the engine needs, which can vary based on factors like engine speed, load, and throttle position. The last classification is based on motion, making it known that pumps can be categorized based on the type of motion they work on. As a matter of fact, this classification can also describe the further classification of the positive displacement pumps. The first of the kind, the rotary pump, these pumps use rotary motion to move fluid. Examples include gear pumps and vane pumps. A gear pump is a common example of a rotary pump. So it consists of two gears, usually rotating in close proximity within a casing. As the gear turn, this creates a sealed chamber that draws in fluid at the inlet side and pushes it out at the outlet side. So gear pumps are often used for transferring fluids such as oil, fuel, and hydraulic fluids in automotive and industrial applications. The second of the kind, reciprocating pump. Reciprocating pumps use back and forth motion to move fluid. The piston pumps are a common example. It operates by moving a piston back and forth within a cylinder to create suction and discharge phases. So during the suction phase, the piston draws fluid into the cylinder, and during the discharge phase, it pushes the fluid out. Reciprocating pumps are used in various applications, including high pressure water pumps for cleaning, hydraulic system, and some type of hand pumps. So remember that this can also be considered the further classification of positive displacement pump. Now, my friend Nimal Hamo is going to follow up with the gear and gerotor pump.
Thank you, Trinchodan. Now I would be talking about external gear pumps. External gear pumps are positive displacement pumps commonly used in various industries due to their efficiency and reliability. At its core, an external gear pump consists of two gears, a driving gear and a driven gear. They rotate in opposite directions, forming tight, intermeshing chambers between the teeth. The working principle is simple yet effective. As the gears rotate, fluid is drawn into the chambers and then, through the rotation, it is pushed out, providing a steady flow of liquid. Notice how the meshing gears trap the fluid and carry it from inlet to the outlet, creating a continuous flow. External gear pumps are most commonly hydraulic pumps in low pressure ranges due to their long operating life, high efficiency, and low cost. Application of external gear pump includes machine tools, mining industry, power generation, aerospace, and defense. Now, onto the internal gear pump. Just like the external gear pump, the internal gear pump is a type of positive displacement pump that utilizes the interaction between two gears, a larger external gear and a smaller internal gear, to generate flow and provide hydraulic power. Crucially, there's another key component in this design, the crescent, which maintains the seal between the gears and the pump's housing. The key to its operation lies in the precise meshing of these gears within the sealed housing, which creates chambers for fluid and ensures a continuous efficient flow. As the gears rotate, fluid is drawn into the expanding chamber formed by the teeth of the gears. The crescent ensures the seal is maintained, preventing fluid from leaking back into the inlet. Subsequently, the fluid is carried to the outlet side as the gear teeth mesh, delivering a consistent flow. Its glaring advantage over the external gear pump is its more compact design. Application for internal gear pumps, food and beverage processing, chemical processing. Now to the Jordan.
Lastly, we have the Gerotor pump. A Gerotor pump is yet another type of positive displacement pump that comprises of an inner rotor and an outer rotor. The inner rotor typically has one fewer gear tooth than the outer rotor. The difference in tooth count creates an eccentric motion when the inner rotor rotates with the outer rotor. The core difference in comparison to the traditional internal gear pump is that it does not use the crescent. The eccentric motion is crucial to the pump's operation. As the inner rotor rotates, it meshes with the outer rotor, creating expanding and contracting chambers. These chambers draw in fluid through the inlet and push it out through the outlet, providing a continuous flow. One notable advantage is the elimination of the crescent, which simplifies the design and reduces the risk of leakage. This contributes to the pump's high efficiency and lower maintenance requirements. As we wrap up this presentation on hydraulic pumps and their classifications, let's reflect on the essential insights we have gained. Hydraulic pumps are the core of the powering industries worldwide, offering a range of solutions tailored to diverse applications. We explored the primary classifications of hydraulic pumps, each with its unique strengths. The external gear pump a workhorse known for simplicity, reliability, and versatility. The internal gear pump, with its precise control and compact design, and the Gerotor pump, distinguished by its innovative rotor system, offering efficiency and reduced maintenance. Understanding these classifications equips us to choose the right pump for the right job, ensuring efficient and reliable hydraulic systems. We appreciate you joining us on this journey through the world of hydraulic pumps.
Feel free to leave a comment below and do not forget to like, share and subscribe for more fascinating insight into the world of technology. Thank you for watching.